Assalamu alaikum. My name is Shahiruddin Ahmad, and today I am here to present my OS project for the semester 2025 with the instructor Nadeem Kafi. I am presenting a NERV Terminal, which is a modular chat-based application that supports both server-based as well as peer-to-peer communication. This application was built on C and it uses N-curses for UI as well as socketing for networking. This is the basic files of the code that are present in the GitHub repository. My team members were Mohammad Fazan, Javed, Shayan, Mustafa, and Shanur Ahmed. The project file structure is somewhat as follows over here. Now, what I worked on was the server part of the whole project. So now let's get straight into the server. So over here we have the server.c file, as you can see, which has only one main function inside of it and a create server function. What the create server function does is it creates a server and allocates sockets and stuff. So let's look into that code. Here we have all the included libraries in order to use their functions. These are the standard libraries. These are some socketing libraries, our thread libraries, as well as assist/queue libraries, which is a system queue library for which we have implemented a queue system in order to handle client incoming connections. These are some macros we have used in our project. Here we have a server file descriptor equals to -1, which ensures that the server is currently not running. We have a data structure of struct type in client info. Basically, this contains all the information about our client, such as their name, IP address, port, socket, their index, and their P2P port. Now we have a data structure of connection queue. What this data structure contains is it contains a client socket, its address, its IP, as well as it tells the connection queue that it is present in a queue of in a system queue. This basically initializes our queue to know that a connection queue type can be included into the current system queue. Moving on, we have defined a head connection queue. Here we have our conditionals, our queue conditional as well as our mutexes. We have defined an array for clients in order to know how many maximum clients we can have. Here we have the count. Then we have a client's mutex in order to handle our clients communication between each other. Similarly, now over here, when this line of code runs, we know that the server is currently running. Here we have some functions that were explained there. These are used to handle peer-to-peer connections and peer-to-peer invitations between different clients. Similarly, here are some function declarations which we will discuss. Here we are actually setting the head of the queue. So what's basically happening over here is that we have implemented a queue-based system for which the server receives client connections through a queue to which multiple threads are assigned from a thread pool. We'll see the implementation further. Here we have a SIGINT handler. It prints a SIGINT obviously message. Then we have over here an unlinked log file. So what basically is a log file is that a log file is a system file which ensures that there is no type of any other type of server running on top of the computer if one server is already running. If there is a server, then close that server and say the server socket is closed. Over here we are creating the server from the main. We have initialized our signal handler in order to tell that the default signal handler is not to be used. We have our socket address over here as well as the option for the socket address because there could be multiple types of connections. We have initialized our worker threads over here. We'll discuss worker threads in a minute. Here we have initialized our connection queue in order to tell it to try to accept connections. Here we have done some socketing in order to set up our server. Here the server file descriptor is checked to see if the server can actually run. The sockets option is set, as well as we have initialized all of the server details. Then we bind the server to a specific address and a port basically to to ensure that it is binded to that local area network, because this is actually a local area this actually works on a local area network. Here the server starts listening for up until queue size. Then we have print a message server listening on port. Now over here we are using multi-threading. As I mentioned before, we are using a thread pool in order to manage all of our client connection. So over here we have created worker threads for initializing our thread pool. Now the main logic of the server run. So we say while the server is running, we have defined client addresses for different type of clients. If the client's socket is less than 0, then we will say accept. Now we have initialized our connection queue of type with the name item. If we say that if the item is null, then close the client socket. We have initialized all of our item of the clients, what they can be and what they should be. Over here we have utilized a mutex in order to ensure that there are no race condition while a new connection is added to the queue. So basically we ensure a lock, then we insert a connection as you can see with the item and the entries at the tail of the queue to ensure that we are implementing a first in first out scenario. Now we have given a signal, which I will discuss later on what this signal is actually doing. Similarly, we unlock the queue mutex, and this keeps running while the server is running. After the server is given a stop signal, then we say that server running equals to false. Pthread conditional broadcast, I will discuss this in a bit. Then we join all the worker threads that were working in order to ensure that no worker threads are left and the main waits for all the server threads. Because there are a lot of clients, and so that no clients can actually be left out before when the server is closed. So we implement a lock for the clients with using clients mutex. We close all of the client sockets, then unlock it, and then we close the server to ensure that each client is disconnected from the server. Over here we have the log file implementation, like I said, so that no two server can run on a single computer. We say if the access is okay, that means that if a server is currently running, then print the error message another instance of a server is running. Otherwise, open a log file and create it, or if it does not work, just print an error. In this function handle P2P, it is accepting a client socket as well as a target name. What a target name is, basically it is the name of a person who is currently connected on the server. Our implementation shows that we can contact each other through the names of the person who are currently online at the time. As you can see over here, since we need to handle a peer-to-peer connection, therefore we have to lock the current client section. We request the client info, we initialize it to 0, and then after that we for all clients check which client socket matches the current one. So initialize it to that. If it is not found, then unlock this and continue with the error message. If the target is found, we will go with target name is 0, then send equals to 1. If a client exists in the current names of the list, then we will lock the client's mutex, send the invitation to the current client, so that you could say that no information could be jumbled up until the invitation reaches to the other client. Then we unlock the mutex. If the target is not found, then print the message to the user that the current client is not found. We use send and recv multiple times in order to show that how socketing handles connections between multiple clients. Similarly, if none of the above work, then we will unlock the client's mutex. Here we have a client handling function. What it accepts is a name, an IP, a port, and a socket. Now again, because one client can be added at a time as per our queue, so we lock the client's mutex. We check if the client's mutex are currently more than the maximum limit. We have a limit. Then we initialize the name, the IP, and the size to 0. We copy the name and the IP from the current function variables, similarly the port and the socket. We say one client has come in, so client plus plus, and then we unlock the TrueTick and broadcast user list. Broadcast user list will come in a bit. We have the remove client function over here with the index. What this actually does is whenever a client leaves, the other user has to know that the client has currently left. So we use a remove client function over here, which locks the client mutex again to communicate to every client how that the user has left. We say if index is less than 0 or the index is greater than client count, then unlock the client mutex, which means that it's a false index. Otherwise, close the client socket at that specific index. Later on, in order to update our user list, we say that shift the remaining clients to the to the position of the other client in order to show that there was a space left. Now the other client can have a higher level. Again, we say client count minus minus and unlock the thread and broadcast user list. Now we have the function void broadcast user list. We have a size, how much size a user will need. We once again lock the client mutex in order to ensure that no information is jumbled up as one client is working on registering. So when a client joins, its name, IP, and port are communicated to other clients in order to ensure that the current or that every client has the name of that and the person's port and IP to show that the person can actually connect with the other person, that they have the same network. So we have the first pass to see how much size is needed. Then we allocate some buffer for it. If the user list cannot be allocated, then we obviously unlock the client list. We say users, which you will see currently on my demonstration. Secondly, we build the string in order to show which client has currently joined. Then we send it to all the clients currently present on the server to update their display as well. Then we free the user list at the end when all the list is broadcasted, and we unlock the client mutex. Now here we have the main function in order to handle our clients. We have a client socket and a client address. We make a temporary client IP as well as buffer to handle our clients temporarily. We convert the client's IP address to a readable format in order to display it to the users. We receive the username and local IP from the client through recv. Like I said, we are using socketing, so we use send and receive v in order to receive data from and through server or other clients. When we use send, we basically send data and it goes through the socket channel, which ensures that whenever we have receive v, it checks the client socket for incoming messages and accepts connections. If there are no bytes received, then close the client socket because there is no need for data to be received. Otherwise, if there is some data received, then we print if a new client has joined. We initialize the username and local IP because since it's a string which comes jumbled up through the socket through the network, because a network can only process words through it at the current time. Then we lock the client mutex to process some information. If the current username which the user currently entered is the same as some other username, then we say that the username has been already taken, close the current client socket and unlock the client mutex. Otherwise, just unlock the client mutex, add the client to the queue currently in order to add it to the connection. Send a welcome message to every single server, to every single client through the server. We once again lock the client's mutex and send the welcome message to every single client to ensure real-time communication between every single client. We unlock the client, and now we'll handle the main chat loop to handle client messages. So we say while infinite or while the server client keeps on talking, we initialize the buffer to 0. We receive the incoming message from another client if it exists. Then we have some messages for the client itself, which is /quit, /connect, and P2P port. What /quit does is basically it exits the current session and gives the signal to the server that the current client has quit. If it writes /connect, then it will handle the P2P request as I mentioned above, that /connect and then some type of name or target name, you could say. So the target name is added to the buffer, and then it is sent to the handle P2P request function, which sends the peer-to-peer request to the target client. Here we handle the P2P port. We have made the P2P port into a value. Then we lock the client's mutex to check the client port as well as the P2P port, because since for a peer-to-peer connection to occur, what we have applied is that for a peer-to-peer connection, the clients can basically connect to each other by becoming a server by itself. This will be explained in the client p2p.c and p2p.h later. Then we say that if there is a slash, because slash are special characters, then ignore it. Then once again we'll lock the client's mutex and send the details to everyone who has joined, who has not joined. Moreover, we have that if the sender not equals to -1, which means there is a sender. So we have two types of messages: formatted messages and sender messages. I will show you in the demonstration what exactly is the purpose of formatted and sender, but just know for now that for a formatted message, if you are currently the client who is receiving the message, then he will get the formatted message. If you are a sender, then you will receive a U with the message sent to all clients or sent to the current client. Then we unlock the mutex in order to ensure that for all the mutexes locks that were applied above, we have to ensure that during networking, no threads can actually access the data of the other clients. That's why we have used a lot of locks. If the client disconnects, we say that found index equals to -1. We have said that if the client socket equals to client socket, then we say that it is found, just in case if there is an error in finding it. If the current client is not found from all the socket present, then we lock the client mutex again, and we say that if found index not equal to -1, then we send a message to every single client connected currently on the server that this specific client has left the server. After sending that message, we unlock the client mutex and we remove the client that just currently left the server. At the end, we send the current client who has just left a disconnection message and close that client socket. Here we have the P2P invitation function, which we saw above, how we can send P2P invitations. We have a requester name, the requester IP, the requester port, and a target name. This is received by the person who is receiving the P2P invitation request. When we wrote the /connect peer name, the name that's written there will receive this function. Here we will say that P2P invite is requested from this. We will lock the client. Then we will check if that client actually exists. Then send an invitation to it and unlock the client. Now this is our last function. For the server.h function, we have a thread worker function. This is used to handle the connections between multiple clients in the form of a queue. So what actually happens is there is a void thread worker, which is the thread as we saw in the create server function. Over here we saw how the create server function creates worker threads, and it initially uses the function thread worker. Now moving back to the thread worker function. Now what thread worker is basically, since we have utilized a thread pool in order to ensure that a thread is ready whenever a client connection comes and it is assigned its dedicated thread, we say that while the server is running, initialize the connection queue Then we lock the queue mutex in order to ensure that no other connection can come in and replace the current connection in the queue. We say that while the queue is not while the queue is empty and the server is running, then we apply a pthread conditional wait, which means that if we have a queue and then there comes in a client or multiple clients for that matter, if there are no connections to it, then we say that the thread can wait for now. The thread will wait. But if the server is not running, then we can just unlock the queue mutex because there is no server to actually send the connection to, so there is no need for the queue. Now over here we will receive the first item from the queue, which is basically the head of the first in from the first in first out scenario. We'll receive the first item or the first client connection. If the item is null, then remove the first connection and move the queue forwards. Otherwise, over here we will unlock the queue mutex because now the data has been added to the queue and now we can process it. Now if the connection was retrieved, handle the client and free the memory. If the item not equals to null, then we will handle the client and free the item currently which is present, because multiple shared memory data can occur there, therefore free is actually necessary, and then return null. What actually happens over here is that whenever a client connects, it sends it to the handle client function, which for that specific thread handles that specific client and sends it messages and different information about how the server works. Now as for my demonstration, I will make first of all, then over here I will run server.exe. Now as you can see that server is listening on port 8080. We have utilized port 8080 in order to use it because it's one of the default ports. Now let's say a client connects. We say that client.exe. Let me enter share here. As you can see over here that now Shahir has joined in the online user system. This is from the update broadcast list. This updates the current number of users inside of a client. Here we have all the chat systems from that I currently discussed with you. As you can see that if another person message, it receives a formatted message in the form of its name. If you yourself message, then you have a U. Similarly, if I write hello over here, this sends the message of hello. Now let's make another client file. Username, let's say Faizan over here. Similarly, he also receives his own chats and the chat from me. Now if I write on the message hello, what this actually does is it updates this UI thread to ensure that only this UI thread is currently working instead of these. Now when I print the message, it says you hello. This is the current non-formatted message that the current client received, whereas the client over here received a formatted message with the name of the sender and the hello over here. As you can see, this user list has updated. Now let's say that I want to leave over here. When I leave over here, the other client receives the server message that I have left the chat. This happens in the remove client function, and this ensures that the socket for that person is closed. As you can see, now let me show you over here that from the server side, the server has printed a message to itself that a new client has joined with the address, network address of this. Its client port is this and its P2P port is this. Similarly, another client joined, the port is this and the P2P port is this. Now let's say that this client is currently running and the server disconnects. Let's see that scenario. When I press Ctrl C, it says that it receives a signal and the server socket is closed. Over here, the client has disconnected from the server, so it's given the message in order to end its own connection. Alright, so now there is one more thing that I worked on, and that is inside of client.c. I'm at client.h. Alright, over here. So what I worked on was the logging function that, as you saw over here, it's not really a logging function. It's more of a saving chat function. So as you saw over here, that whenever I log in to a specific user, we have a you hello there, Shahnur, hello, what's up. So basically what this is actually doing is it is retrieving data from a log system, from these log folder, where I have the .json file for every single person. So this was my implementation. What actually happens over here is that we read a file, we open the file pointer, we use filing techniques in order to ensure that that the current file exists and that it is readable. Similarly, we write to the file. Here we have Here we are utilizing a library in the utils folder, which is called cjson.h. It is a free open source library present on GitHub that we have utilized in order to implement our logging function, because JSON is really lightweight, and we already have a parser for it. So this is not a part of our project. This is used to implement logging for our project. This is an external library that we have included. Here we have the write file function, which prints the cjson print JSON. This gives us the JSON string that is currently present inside of the whole JSON file. As you can see over here, all this string. We say that if a file pointer does not exist, then it failed to write. Otherwise, printf the string that was currently sent, and then free the JSON string in order to ensure shared memory access. Now, what happens in the void display previous chat function? What this actually does is that in order to display the previous chat, we have to know if the current chat exists. Now, let me show you something that if I say, let's suppose I say Ahmed. He's a new person who has never joined the server before. When I say it, a message displays that no previous chat was found. Although when I write hello for it, a JSON file is made over here for Ahmed, which ensures that that file exists. So as you can see over here, that we store the file path for the username that was actually sent. This username is accessed globally in the client. You can see it from the client side of my teammate's explanation. We have the JSON data. We read the file inside of ahmed.json. If there is no data present, like similarly as I just demonstrated, then we print the message that no previous chat was found. Otherwise, we take the root, we parse the JSON data. If not parsable, then print error. If there is if it exists, then we have a messages variable which takes from the root the column of message, as you can see messages. And then if that does not exist, then we say get no messages found and then delete the root. If the chat array exists, because there are multiple messages for multiple functions, as you can see over here that we have a global and a Cheyenne function. What this actually shows that for the global, this is this server. For peer-to-peer connections, I implemented a name-based chat array for messages, which is a dynamic array which will contain multiple hash keys, which will be mapped to the username in order to ensure current access, in order to ensure that whenever a client peer-to-peer is loaded, it is also loaded with the same chats. After that, we say that the message is null and bring every message from the file into the chat array and display it on the current terminal, and then delete the root. Another function we have is update log. This is basically used every time a new message is added to the chat. Like if I add a help, it is immediately updated in the chat log that I wrote help. Similar stuff is done as done above. Then we say that cjson add item to array in order to add it to the array, and write it to the file that is present over here of .json file. So this was the implementation for our for the logging that I implemented. Now, one last thing that I wanted to clarify in all its clarity is the queue structure that I have maintained. When a client connects, the main thread says to create a server. It accepts some kind of connection. It creates a connection queue and initializes the log mutex in order to ensure that there is actually no other connection can be accepted by the client. We insert it to the tail. We signal the conditional queue conditional to actually unlock. Now, what I didn't mention before was that whenever we are using conditionals in order to signal the queue, so all the threads are currently in a wait state inside of the thread pool, where with waiting and not using any kind of resources in the current moment. Whenever we have an insert at the tail, then a single thread can awaken and access that and be assigned to that current client connection in order to ensure server client connectivity. Then it unlocks the queue mutex. If there is nothing present, then once again, because it was in a while one loop, so it accepts another connection. Otherwise, it waits on the queue conditional. Over here we have the worker thread function, which when locks, we lock the queue mutex. If the queue is empty, as like I said, queue is empty, then it waits on the queue conditional. After the signal is called, it moves over. If the queue is not empty, then it is inserted in the FIFO, basically first at the head of the queue, and after it is handled, we dequeue the entry. Here we unlock the queue mutex, we start handling the client until it exits, we free the entry, and once again loop to wait for the next entry. So this was my contribution for the project of the server side of the application. Now Shahnur will take away to explain the client side of the whole project.
Assalamu alaikum. This is Shahnur Ahmed, and I will be explaining my part of code in the OS project. My team members are Shahir, Fizan, and Shayan. Our project is the NERV Terminal. It's basically a chat-based application which I have worked on the part which is handling client. So I will be explaining some functions of client.h and explaining client.c, that how is it working, because in our client portion also there are some things which are done by the other member, that is the peer-to-peer connection between clients when they are doing private messages, and some other things which are the UI based, which are already explained by my other team members in the other videos. So here is my part to demonstrate. There's no need to demonstrate the although I can demonstrate the project, the working of it, but there is no need for that, as already my members have demonstrated how the project is working. The UI is already very clear. I will be explaining the code directly. So in client.h, basically this file is run whenever a user runs the client.exe. Basically we have a single server.exe in different, and we have a capacity of maximum number of clients allowed. That means that on that many terminals we can run the client.exe that will make a client, and for every client this code will be run, that is it checks for that if the log folder is not here. Basically the working of log folder will be explained later. What it does is that it saves the state of data. So if a user starts for the very first time, when we have the very first user on the chat application, obviously he will create the log folder, that is directory in Linux, and basically at the end of his chat, when he will be quitting, his chat will be written to this function, will be written to the to files created inside this directory. Further, when other clients will join the chat, the folder will already be there, so this code won't be executed. I have already taken a lot to explain this chunk. I won't be explaining in that detail, otherwise the video is going to be too large. So we'll be covering an overview of the code. Then it handles the signals, that in case of control C and username and struct UI, these are the functions that were explained by my other members. Basically this function here creates an IP, and IP basically throughout our chat application we have used socket programming, and obviously we didn't have a full course on that, so we aren't that familiar with that. And on my behalf, in my part, I have taken a lot of help from internet resources like ChatGPT and DeepSeek to implement the problems related to sockets and IP addressing, and I am also not that comfortable with them, but I have developed an understanding. So what basically this function does is that it creates a socket, and on that socket it is going to apply, you can say that apply for a connection, and if this function, that is the this end of function, basically it fetches the IP and converts that into a local IP name variable, that is the human readable IP. It gets it from it gets a IP from computer and converts into a human readable IP form. And basically this line here, it tries to make a connection, and where current socket, it will get the socket number, that is it will be it will become successful in establishing a connection. Basically what happens is whenever new client join, it directly, whenever new client joins, it applies to get a connection with the server, and this function does it. And when then chat loop is called, and basically we will be explaining this function after the client file is run, and chat loop will totally it will control the part of client. And these are just this code is written when the client will be exiting, his socket values will be changed to -1. Basically they are here for our understanding, that is he connected to socket currently or not. P2P is explained by the other member, and these are just UI functions already explained. So we will be moving on the client.h, that is some of it is my implementation, and rather is explained already by my friends. There are some already defined macros, that is the maximum number of characters in a single message, maximum number of users. They don't need any more explanation. This is basically an input mode, that either he is inputting the user is in normal mode or P2P mode. P2P mode is obviously the private connection, and the connection type, that is also the connection server is the user is connected to the server or the P2P. So basically for every user we save the user's name, IP, port, socket, and these are some UI things which are already explained. Now the initial function of this file are obviously the P2P, which are explained by my other member, I guess Cheyenne. So we'll be skipping these as they are already been explained. This connect to server. So when the connect to servers function was called in client.c, it fetches the local IP, and it tries to establish a connection between the client and the server. So here a socket is created, and here, as I told you, that init python, it converts the IP into human readable IP, and we basically take the user's name, which as far as the client file runs, we take the username, and that username and his IP address is basically sent to the server to request for a connection. And next is peer-to-peer is already been explained. These are some UI functions which I won't be explaining. Get username is already done. Yeah, add message. So basically add message, receive message, these functions I am going to explain this, but let me first go to the chat loop. Basically the whole client, the crux of the client file is in the chat loop, that how he is chatting. There is an input message, start P2P listener. These are the functions that are not my part. We said it is lock if input. Basically what happens is that this code is also handling the P2P, that is private messaging. If the user accepts or rejects the private messaging, that is in my part. Now here it is in the chat loop, if the user enters the tilde, we have made the code that he will be exited from the chat. This code is here to check if a user has pressed enter. If he has pressed enter and the line is in empty, that means that a message is being completed and he wants to send that message to the server, and the server is going to distribute that message to other users. So this is check if he is requesting for P2P client. This is also here to give him the authority that /connect the username. It connects him to the other users private space. Basically this handles the backspace, and it makes sure that apart from backspace and enter, no other special key is detected in our code. Okay, so I don't know what's happening there. Are you still there? Yes, I'm still there, bro. I hope so. It's been recording correctly, because I've already been speaking for 7 minutes, but if I find out that it wasn't recording. So basically this was chat loop, and let me explain you some other functions. That is read file. Read file is basically a very simple function. What we are doing is that whenever a user joins the chat, he is going to do some messages on the server. Later on he might request for a P2P connection, which in case he gets, he might message a person directly in the private space. So in our case, when the users are writing to the server, whenever he exits, all the messages he wrote are written in the file that is saved in the log folder. I initially told that we created a log folder and the write file is basically here to, whenever a user comes and if he comes for the first time, obviously his chat history will be clear. But if he comes a second time and has already done messages when he joined first time, all the messages which he wrote for the first time will be brought back from the data, as we have already saved those files, just like in our WhatsApp or in any other application. When we rejoin it, our chat history is already there. So this is all two important functions that are receive messages and send messages are remaining. So send messages here, basically to send a message to a server. It also contains a buffer to ensure that it has been written in the maximum limit of the buffer allowed. It checks for a few things. For example, if I am writing some message and some scrolling is required, so I have written code to handle scroll, to scroll down to the screen. Word wrapping logic. What if I am writing and I have reached the end of line and word is incomplete, so it makes sure that the starting of the word is shifted to the next line, so that there isn't any word that is written half in one line and half in another line. And it also makes sure that if the user writes for more than one line, whenever he is overlapping the line, whenever he is going out of the boundary of the line, the variable is incremented to make sure that, to indicate that a new line is being written and the first line is being written and new line starts from the very beginning, just to make sure that it is written line by line. Now in receive message, the purpose of receive message is to receive the messages from the server. What the server does is that when a single user writes something to the server distributes that message to each and every client. So how does it does is very interesting. It sends a message like code, like in encoded form, like it will be a username, his IP address, his message. So it is a format. The format is written in the server.h file. That message is sent to the receive message function, and what receive message function does is that it first checks that it is sent by the user or chat user to distinguish between users are users which are everyone who registers on the server is a user. Chat user is a user which is currently active. So what does it does is, as I already told you, that the message is kind of encoded. So it decodes that message. It first removes a comma to make sure that comma to identify the different entries, that is the name, IP address, and the other entries as well. And then it uses the string manipulation to extract those. For example, question arises that why does it extract when it receives? It does so because the client function, what I have to say, it maintains the record of who is connected to this client, and sends the message to maintain this record. What does it does is that it reads the message, although it displays it, and it saves the person's name, IP address, socket into the peer list. So it maintains the record of who is this client connected to, whose message is this client reading. As I told you, that shared user and user is just here to distinguish, just like as I told you before, string manipulation is done to save his data in the above. In the above structures we have declared, this is the P2P connection which is in my part, and then obviously the message written is sent to the add message function, which adds a message into the you can say whatever I have to say into the servers. And one last function which I am remaining is the update user list. Handle signet is obviously there. If a user presses Ctrl C, we allow him to exit from the chat. Handle P2 update client list. Where are you, go? There is update user list. What update user list is does is that first of all, let me tell you a few things. We only allow writing 5 users at a list. I will be showing these something by demonstrating by running it once, so that all what I am saying might become more clear. We basically allow displaying 5 connected user on the screen, although there might be 10 connected user, but because we have limited size on screen for the display area, what we do is we provide with an extension that is plus D. If we have 10 connected users, we will only display 5 users, and then we will display a plus more symbol, just to indicate that we have more users as well. And we have the mechanism that when he will try to establish a connection, he will be shown that whoever is online, so he can make a connection with his person he wants. And then we have a refresh thing. Basically the refresh here is a bit different from, you can say, what we used to do on the terminal. That is, if we are writing something on the terminal and if we want to update it, we first clear the terminal, we then write the new data. Whereas in the update usually the incursive works in such a way that when we were updating all these things were all written into the buffer of incursive. It doesn't write it directly to our terminal. What happens is that we call these two functions, then it does clear the terminal and it rewrites that. So initially it was not written in the terminal, in the incursive buffer, and when these functions are called, it brings that to the screen. And that was my part, and that's all from my side. Thank you.
Okay. Assalamu alaikum. My name is Faizan, and my contribution to this project was integrating our UI to this project, and along with that, how to call our client P2P executable file through forking. So let's get started. For our project, we use the N versus library for our UI handling. The neat part of this is that you can create multiple types of like windows on your terminal and manipulate them according to what you need. So let's get started from our main function in our client.h. I have defined some user defined functions like get username, init UI. Along with that, later I have applied some UI interfaces in our chat loop. In our get username function, we can see here we have used some library defined functions like init screen, cbreak, keypad, which just initialize the screen like this. Cbreak just breaks the line buffer, and along with that, keypad just allows the movement from our keypad, start color, so that we can apply different types of color to our terminal. Here we just see that if we can change the color of our terminal, we can apply like different types of RGB values to our custom made IDs. Like we have defined here a custom color ID. It's a macro right now, which is the of 10 value. They are mapped to like integer values which can be used to set colors later. Similarly, I have defined, oh, not here, now I get username, which will be here. After applying that, I cleared and refreshed the screen, and later I have created a new window. This is the library defined feature as well, in which you can create a new window along with the x-axis, y-axis, and where to place it and how much space should it occupy. This is another function in which you can apply the border of your window. I can show you that real quick. First of all, let me create the server, launch another client. Yeah, and there we go. This just prints in the window you want to specify, like I have here done for my uname window. This is the x-axis, this is the y-axis, and the custom prompt I want to use, like on here. This is the 1 coordinates relative to this box. Print that, and here you can just print whatever you want, which is being done by this function here, which allows you to enter to like get any string and store it to your username. This here is just a global variable, and get into your input window. I have just cleaned it up here, delete the window and clear and then refresh again. After that, now client.c getting a username, we have initialized our window. It's defined here. Similarly, I have initialized the window, set it some background colors, and applied integer and applied like different color gradients to some integer values, like mapped them so that can be used later. Here for our title, we have made a custom 2D array which I can show you that right now. Yeah, it will be from the middle of the screen, occupying a small amount of space along with different shadings of color, which I have defined here. What this does is just get the height, width, center, and along with that the number of rows right now. What I have done here is divide the 2D array into a bunch of chunks, like from here to here and then from here to here similarly, and applied coloring to that and just printing it using our NCurses library. This part does that. Napalm is just NAP-MS, yeah, is just used for delay. After that, I have calculated the remaining height. Lines is just library. Lines is a macro in our NCurses library, which gets initialized when our new terminal is created, and we can use that to sort of like what type of formatting we are going to use. I have created more windows like chat, user, input, like this is our chat, sorry not this, this is our users window, and this is our input window in which I will show you that later. Apply, and this is some features for our windows, which is done through NCurses library. Next up is our chat loop. My main functionality in this was again applying the UI in this. I can show you that this is going to be our main thread, in which I have created another thread called receive messages, in which we are going to be receiving messages from other clients, which will be explained to you by another mate of mine. For now, I will show you how we are getting the characters. It's just a simple while loop in which we are getting each characters and printing it to our input window. I will explain this part to you later. For now, this is the main part where you can see it. This just tells what position the first pattern is. Like right now, this is our first position, and later it just increments and show what you have written. It's not that difficult to understand. It's just using some of the functionalities of our NCurses library and just printing it on our screen. This just gets if the character is valid or not. I will explain this to you later. Well, not really. After this while loop terminates, we can just join our receive message thread, which I have created above. In our receive message, we have created the threads getting its data. In our while loop, we have used add message function. Here, this part is really just used for this part is really just used for printing it to our screen, but its main purpose was to show that if any message shows up, we can just add it to our terminal. Buffer just means that we are getting string from the server or any other client. What this function does is that it just prints in our screen. Like you see here, if I press enter, it will just show you on our chat window where we have written it. Goes down and just prints relatively in your chat window. What this does is just gets the maximum height and width of our chat window, get the available height in which we can write, -2 because we want to get rid of the borders, and apply formatting to tag. We have given it a what do you call it, string, string, and just copying into the buffer so that we can print it easily. What this line does is just print one by one each letter to your screen. This part does that, get the available height and apply wraparound logic. Along with that, apply the this part does the wraparound logic, and this part just allows you to scroll downwards on your screen. I can show you that as well. It's gonna take some time. Yeah, see, it goes down, and if I were to write like a big string, it will just wrap around, like it will go down a line. Yeah, there we go. And then refresh the screen with their respective parameters as well. Now for my P2P connection handling, I have done that in my receive message function. Okay, this one is bad. Receive what? Oh, never mind, there it is. There will be an invitation part here, in which the buffer gets a string if it happens to be the same as in white string. It's compared, and this if condition executes, we get our inviter name, inviter IP, and after that we handle if it's valid or not, and later we apply mutex lock to it. Why? Because as you have seen, our receive function is receive message is where printing is being done from our other screen. Printing is being done to our other thread, whereas in our chat loop we are getting the actual input itself. Here we are going to get the input to our response, so that's why we have used mutex lock here to avoid race condition. After applying lock here, we just simply go to our chat loop and get our input there. I have also initialized them on the top of our header file. Yeah, here input mode is just our custom enums for readability, input mutex, and input conditional so that this thread can sleep until we get the signal from our chat loop. Okay, I can show you chat loop. Yeah. When every time I get a character, I apply mutex lock. Why? Because I have already told I want to get the response to it. The other thread allows the input mode to change so that this if condition can be executed and get the P2P response from our CH buffer. This is acting as a buffer right now. After that, I just signal our thread so that the thread above can start executing. And yeah, I have applied unlocking to this thread, so we have exited our race conditioning part. This is really just an exit session, and continue so that we can execute our loop again. We will just ignore this after continuing. In this, after getting our input, staying in this while loop, after getting the signal, this while loop will end, and consequently, if the P2P response that we have gotten in our chat loop is Y, we can just add to our current message, add a message to our screen on our terminal really, and launch the P2P connection. So what this does exactly is launch our server and our client. In both of these, fork is being called to create a child process from its respective parent process, and apply formatting to our buffer so that we can pass it as a parameter, command line parameter. execLP just replaces our current process with what we want to execute. X terminal is a sort of terminal. We are doing this since we are using WSL for simulating Linux. Apply some features to it like geometry, and this just means what type of ratio I want the new terminal to be. Along with that, allow coloring to be used. If the default one, instead of using this, if we were to use a default one, we cannot apply color to it. This is another parameter and some more parameters. Same with this. The reason why this one in this sorry in this terminal we are sending a server command line parameter, and in this client is so that later we can confirm which is going to be the server and which is going to be the client in our client P2P executable file later. So yeah, this is it. This is how it's going to work. This will just return the process and will be running side by side depending upon our scheduling systems of our PCs. And yeah, that's my part.
Starting with the search channel, we explain to the side of our project in our terminal. So we implemented chat room application, which has both logic for chat room application and P2P peer-to-peer connection. It means personal chat implementation. So I myself implemented the client underscore p2p.cm.h file. So today I'll be explaining that both those files and the logic behind that file. So this is my GitHub account. I will be first of all going to the repository. We have implemented a project. This is the OS project 2025 repository, and these two files are the files that I must have implemented. So first of all, I will start with the .h file. Here in the .h file, this is the header file, the client P2P. We have included our client.h file. After including our client.h file, we have defined some macros for our UI, custom color ID, custom peer ID, and user display. These are macros for our initialization of P2P UI. I'll be explaining this further later on. So first of all, we have some forward declarations. So here we have 5 functions. First for P2P UI, second for add message. This will add message on a screen. It will update the UI of our screen and add physical message on the screen. Third is the receiver runner function for receive messages. So we'll be using a receive thread, which will be using this runner function. Fourth is display previous thread. It is for our chat history, and fifth is update log. This is for updating our JSON file. So first of all, we have initialized an array of the character type, which will store their username. So we have initialized it with 0. And first of all, we have our function initialize for P2P UI. So this is a basic function. This was implemented by a partner who worked on the UI side of a static application. So we have custom color, purple color, RGB color, and how to the screen will refresh, what is the box size, and all those things for our UI. So this is the implementation for our UI side of a P2P application. So this is the function for basic UI side. So like I said, forward to the our main function, which is add message function. So add message function is it is used to update our UI. The UI we implemented, this add message function will update the UI. So for suppose client A writes hello to client B, then that hello will be displayed both in client A's and client B's, both in both terminal. In client B's terminal, it will be showing client A wrote hello, client A dot hello, and in client A's terminal, it will be you dot hello. So this add message is used for that purpose. We have first of all a buffer, which is using a method of next message. Here we are copying message into a buffer, and in the end of our message we are putting vector 0. After that we are handling logic for storing that if the size of message has exceeded the limit, then we increasing page size. After that we are writing a word, and after that we are displaying a word onto the screen. Here we have described the screen that when client writes hello, then the screen will be refreshed. So the timing is really fast, so we could see, but the screen is refreshed every time. So this is the basic logic for add message function. After this, we have the most important function, receive message function. This is the receiver function, another function for our receiver thread. I will be explaining what I meant by the receiver thread in a moment. So first of all, we will start with our receiver function. It is accepting a void argument, which is most probably this data pointed which is pointing to thread data structure. First of all, we have a buffer of size max message. Here we have initialized the whole buffer with zero value, and we are reading data from a buffer, which is peer username. So the peer we are connecting with, it's his username, and we are also passing that username to the display peer chat P2P function, which is used for displaying chat history. So if client here has already got connected with client A and they both have a chat, then we'll be passing the name of client A to the chat history function, which will be retrieving all the chats and will be displaying onto the screen the old chats. After that, we will enter the loop for receiving messages. Here, we have again initialize every time the loop will execute, the buffer will be initialized with zero, and we'll be using receive system call, and we'll be using socket uh, socket to receive the data from other pair, and we will be passing that data to the add message, and which will be updating our UI and displaying that data onto our UI, and update log which will be updating our JSON folder, which is collecting all the information, all the chat history of between our clients. So this is receive message function. After that, we'll be moving forward to display PS chat P2P function. This is the basic function which we implemented to store a JSON file, and to store history into the JSON file, and to retrieve the history by giving the username of a particular client. So this is the basic function we use uh, to store a chat history and to retrieve a chat history from the JSON file. So this was the whole side of .h file. Now we'll be moving to .c file, and here I will be further explaining the logic behind how we implemented the P2P function. First of all, we'll add include our .h file that we will load and I explain. So inside the client P2P.c file, the main logic is that if there are two clients which are connected to a server, so registered with the server, so these both clients will first of all have a main logic of active socket listening. They will have a socket which will be actively listening for incoming connections, and this socket is implemented right over here. So here, this program will have five arguments. First argument will be the program name, second will be the username, third will be the P2P port which will be connecting to, and other will be the P2P IP. After that, we are initializing an array of max message macro, and inside this array we'll be using this array for string formatting. We'll be doing a string formatting, and this string formatting will do this, that it will display P2P server port, and after that port number will be displayed that we copy from over here, and server IP will be displayed for this is server IP RTR port, and that add message will pass to the time which will update the UI, and we also hard coded it that P2P server had started and it is waiting for connections. P2P server has started. We can say client A has started, client A is waiting for connection. That if client B wants to connect, client C wants to connect. This is the logic for active listening socket. Actively listening socket. Like I said, every client will have its own active listening socket. So if client B wants to connect, then it will come and get connected with this actively listening socket, which is listening every time for a connection. After that, we have initialized and listener. Here we have struct for socket address. Here we have initialized the family of the socket address and the port. After this, we have binded our socket. Binded base, we have provided the port number, the IP, and all those formalities. After this, we are forwarding this thing for our incoming client connection request. So it means client A has successfully created its active socket, and now client A is listed for connection. That if client B wants to connect, client C wants to connect, if any one of those want to connect, then they will send the request to client A, and client A will in this part accept the connection. Here client A will accept connection. We'll be using the accept system call. We will be accepting the connection from the P2P and we'll be initializing this to a P2P socket. If the P2P socket is there with you, it means no one was there or our system error was there and we couldn't connect with a client, with a pair. And after that, if we got successfully connected, then we'll be initializing the peer IP and all those things, the message, and we'll be formatting that message that we have connected successfully to client A or this person or this is with this IP. And we'll be passing that formatted message to our add messages function. So this is the basic implementation of how our listening side works. Now I will be explaining how our client mode side works. Now I will be explaining client mode side. So here after actively listening, we have made a client mode. We are working client mode side. Here we have formatted a message that connecting to this particular server with this particular IP, and we have passed formatted message to add messages, add message function, which will again update our UI and which will update our UI and which will display all the logic in our UI. After we have connected to our peer, we will first of all check that if we are successfully connected to a peer, and if not, then the connection is failed. After we are connected, we will go with this message that yes, connected to your pair and not have your message blue. Now we'll see how the logic works. So the main logic is that we have a receive thread for both clients, client A and client B, and to send message, we don't have any thread. We'll be using the main thread of this program. So receive thread will be making it. So here we have initialized receive thread, we have create receive thread, and now we'll be using this receive thread in this chat loop to receive messages. First of all, if you press tilde, then the chat will be break and the connection will be disconnected. After that, we'll be entering this chat loop. Here we'll be, if client A writes hello, hi, then client B will be receiving hello, hi. So the formatting of hello, hi will be done over here on this side, and that receiving thread will receive that message again, pass it to add message, will format the message to the UI, and update log function will update our JSON file. Here we have again use send system. Like I said, if we have to send message, we'll be using send system call. If we have to receive message, we'll be using a receive thread and receive system call. So a message will be sent through our main thread and receiving thread will be used to receive message from both ends. Here we have some parameter for if user presses backspace or presses enter and all those things. We have double checked all those things. We have refreshed the screen. We have updated the UI based on the particular thing done by the user after a whole implementation. Then we have cancelled the receiver thread. We have destroyed the thread and we have joined the thread in that particular. And in the end, don't forget to close your P2P socket. And then we have closed the P2P socket. So this was the whole implementation of client side, client underscore P2P and client dot underscore P2P dot S side. Here, here we have implemented that how we will be using receiver thread and main thread to send message and receiver thread to receive message. Here, there is one more logic that if with client A have sent message to client B for connection, then again client C cannot send message to client B. We have used locking over here, mutex is over here to prevent the race condition. If client B accept or reject said offer after the client C can formally send an invitation. Here we have also used the logic of sockets. Sockets and they are also a basic IPC network where we are doing inter-process communication through networking. We have used the logic of sockets. We have used emulator, external emulator. Here the logic is that whenever the client P2P site is called, a new function will be called which will run external emulator, and external emulator will help us in making in communicating with each other and communicating with each other via P2P connection, peer-to-peer connection. So this was from my side and for both the things. And then I will be showing you a flowchart that I that I'll be using to explain further. So first of all, we'll be starting then we'll be checking the command line equivalent. First of all, we'll be going in the server mode. We'll be initializing our sockets for actively listening. We'll be initializing a UI. Then we'll create listening socket. Then we'll bind socket like I said. Then we'll be accepting a connection. If that any connection is there, then in the end we'll be closing the connection after we have successfully talked with our peer. In client mode, we'll be initializing a UI. Then we'll be connecting to our peer. And both then after the connection, the message exchange will happen. And in the end, when the message exchange will be finished, it will end. So I have also used flowchart to explain the whole logic behind my code side and the left terminal, the chat room that we implement. I myself implemented both of these uh, sides and the logic for P2P side. So this was from my side and this was from our group. So yeah, this was our from our side, depending left term and chat room applications. Thank you.